Hey everyone, welcome to our presentation. Today we will be talking about CI/CD runner CI/CD tool that we developed to secure runners using Berkeley packet filters. And I'm Mert, and I'm joined by my friend Cenk, who's the CEO and co-founder of Conf42. For uh, introducing our tool, we will first talk about the trend landscape and to showcase why we're developing this tool, and then we will talk about why we choose Berkeley Packet Filter and how we developed our tooling approach, and then we will showcase a demo of the tooling. So if we look at the trend landscape today, as you can see, there are a lot of malicious application in the wild, which dramatically increased throughout the years. And if you just look at the 2 years ago and compare it with the last year, you can see there is a lot of the interest from attackers in terms of malicious packages. And as you can see, there are common attack vectors for attackers to achieve this. The first one being the vulnerable packages. They publish a vulnerable package using typo squatting attack or publishing a package that resembles a legitimate package name that is widely used, so that they are trying to trick the developers to use those vulnerable packages instead. And similarly, they also took an approach of compromising pipeline tools so that they can tinker with them, or they can publish again typo scouted pipeline tool, which might seem benign but might not be. And lastly, they can write out compromise the artifact integrity. So this could be a code or your container image. So they can target those and compromise them in order to, for example, publish or deploy code of their own choice for crypto mining purposes or some other purpose to leave backdoor. So based on these common attack vectors, we can talk about, for example, one of the recent threats that is happening in the wild. North Korea-based threat group recently published, for example, npm package called execution time async, which is a copy of a packet called execution time, which is being used as a code profiler. And this package aims to steal the victim's login credentials and passwords from the browsers. But as you can see on the left side, it also has a Python script capability to further the compromise. Once you have this npm package, it collects the credentials and passwords, and afterwards it tries to download this Python script so that it can remotely control the compromised instance. In order to achieve this, on the right side, you can see the diff of the recent build that was discovered by Phylum. They're constantly changing the IPs to stay hidden. And this has been, if you follow the blog post, you can see that this has been tied to North Korea. And this is not the first time that some threat actor group is trying to masquerade as a legitimate package. And that's why when we see similar threats in the wild, which can affect also CI/CD pipelines in form of malicious packages or compromised pipeline, we decided to develop our tooling, which is also open source, called Control. And now Cenk will deep dive into the Berkeley packet filter. What is it and why are we using it, as well as some of the use cases that we looked at to implement within our tool to monitor and prevent these kind of attacks.
Yeah, thank you, Mert. So welcome everyone. So in the second section of this talk, I will explain why we have chosen eBPF technology to implement this open source security solution. So eBPF technology is gaining more and more popularity in the observability and the security space. And we decided to use eBPF because we want to monitor and prevent attacks or anomalies in the runtime. And since eBPF allows us to write portable applications because of the compile once and run everywhere approach, this was obvious choice. And let me explain you what is eBPF, or let me rephrase once again. So eBPF is a way to write kernel level applications without literally writing or compiling anything in the kernel. And because of this portability approach, when you develop such an application, this tool will basically run any newer Linux kernels, which most of the CI/CD runners will apply that. And so eBPF is basically lets us develop an user space application while modifying and touching to the kernel space. And as you can see in this example, literally writing in small hooks in the specific kernel section or kernel syscall, we can either asynchronously see or monitor the probes, or even modify for some of the probes. And so we asked ourselves, so how to develop and what to do while developing those security solution. And we explored the options. And when we have seen all the attacks and then we have analyzed all the attacks, we have seen a common pattern, which was the network layer. Obviously, we can develop more and more controls and security tooling by using this technology. We started to develop this open source tool with the traffic control layer. And how the system works, or system has been designed is, whenever a new event occurs in the pipeline, we are going to attach appropriate kernel calls, and we create separate sections or channels, send those probes into the user space, and user space will act as a decision-making or policy engine, which will allow or prevent or block the relevant access call. So in the latest attack that we have seen, we have observed the North Korean one, the Lazarus group. This design was pretty variable, and if the vulnerable package has been triggered in the developer's machine, it was acting differently. On this other side, it was running in the Linux section. There was another approach, and so that's why we have developed the monitoring capabilities as well as the prevention capabilities, and added those controls in the tool. So what is the playbook? So playbook, as I explained, first we should decide which events or which hooks we are going to attach. Obviously, we wanted to have the TCP and the UDP connections. So we are attaching the TCP, we connect, and the IP4 datagram connect calls. Those calls are creating dedicated channels into our user space. In our user space, or acts as a policy engine, and whenever a malicious event has been identified, we were basically telling our filtering function or filtering to prevent the access. So this is the overall picture, and our aim, our idea is to develop a full-fledged open source CI/CD security solutions with eBPF power. So let's jump to a quick demo, and let's explain how the system works. Right now, we have developed this as a single binary. So this means that since it's a single binary, and again, because of the core architecture, it will work basically in any Linux kernel. So as you can see here, on the left side, we have run the code, and on the right side, we try to get some HTTP calls from the Google and then the Amazon. Since those are blocked, we see that those TCP communication has been blocked already, and we then created an wallet call and download the artifact. And as you can see, those TCP wgets were successful. Using this approach, let's show us how the same approach will work in the GitHub runner, on a GitHub action. As you can see here, we have developed a pretty simple and pretty valid GitHub action file. So we have two actions here, or two steps. One step will act as a malicious event, and the malicious event or malicious step will simulate an secret leak operation. And on the other hand, we will have an allowed action which will download the artifact or which will upload the artifact. And finally, we will run the, we will see the report. We will just see what's going on. So we are triggering the event, and since it's a single binary and we have developed an dedicated Docker as well, so it's Dockerized. You can run in the Docker format as well based on the CI/CD runner. So control binary has been developed and one action, prevent action occurred. As you can see, the network unreachable, and in the alert action, it works, and down below we have a report that works as expected. What was the idea behind this tool? Obviously, if we can monitor the network or what's going on in the pipeline itself, we can take certain measures, and we decided to develop this in an open source because with the help of the community, security community and eBPF community, we believe we can implement more and more sensors. And the latest version or the new version of the tool supports UDP protocol as well. And based on the configuration, it can prevent access or allow access to the GitHub meta IP range. And in progress feature, we have developed an open policy agent-based rule engine. It's been tested and we will publish soon. And afterwards, we will create an proc monitor or process monitor sensor to understand which files has been accessed or even touched. And we will get a list, and we will try to find anomalies in the file system using the proc sensors. So that was it for today. Please join and contribute to this project. And if you have any questions, feel free to reach us. We are happy to answer or even contribute to your questions. So thank you. Thank you for having the call.